Hello everyone, welcome to my channel. In this video, I will discuss few solved problems on finding equivalent resistance. In the previous lecture, we have seen if two resistances are connected in series, we can write R equivalent equal to R1 plus R2. If two resistances are connected in parallel, we can write 1 by R equivalent equal to 1 by R1 plus 1 by R2. Let us use this concept here. While finding equivalent resistance, you always start from extreme end and then you just identify the node points in the given circuit. Node points are nothing but when two or more elements are connected together, then the common point is called as node. If you observe here, this can be a node point because at this point it is a common point where two or more elements are connected. Even I can take this point as node point. Here also two or more elements are connected. I want to name it as a C and this as a D. From the figure I can see here 2 ohms and this 2 ohms are in parallel. So I can write here 1 by R equivalent among this branch, that is RCD, equal to 1 by 2 plus 1 by 2, which is equal to 1. RCD equal to 1 ohm. I can redraw the above figure like A, B, and this is 5 ohms and this is 5 ohms and this is nothing but 1 ohm. This point is C and this point is D. Now we can observe all these are in series. In series element, voltage gets divided, whereas in parallel elements, currents get divided. So we can write here R equivalent or RAB equal to 5 plus 1 plus 5, that equal to 11 ohms. R equivalent is equal to 11 ohms. This is the answer. Second problem. Find equivalent resistance across XY of the circuit drawn. You can see here we have 4 resistances, each of R ohm, R ohm, R ohm. If you observe the circuit, here you can see current gets divided here, whereas same current flows in this branch. And even here same current flows in this branch. We can say this R ohm and this R ohm are in series. We can write here R equivalent for this branch equal to R plus R, that equal to 2R. Whereas for here these two are in series. We can write R equivalent equal to R plus R, that equal to 2 ohms. Let me redraw the figure now. X, Y. So here one is 2R ohms and another one is 2R ohms. This is 2R. This is 2R. Okay. Now we can write, as these two resistors are in parallel, we can write 1 by R equivalent or 1 by R XY equal to 1 by 2R plus 1 by 2R, that equal to 2 by 2R, that equal to 1 by R. Therefore, R equivalent or Rxy equal to, answer is R ohms. This is the final answer. Next problem, third problem. Find equivalent resistance across the terminals X and Y. You can see here we have again 4 resistors which are like this, and we have a connection here. Let me put the node points here. Just I want to indicate this node as M and this node as N. Node is nothing but a common point where 2 or more elements are connected. And I would like to just keep this as node P and this as node Q, right? If you observe here, current gets divided in this way. We can write equivalent resistance for branch MPN. MPN. Here current will not get divided, so we can say these are in series. Equivalent resistance across branch MPN is given by R plus R, that equal to 2R ohms. Whereas for branch MQN, equivalent resistance is given by R plus R equal to 2R ohms. Whereas the other branch, this branch MN, is a short circuited branch. When we have this kind of scenario, equivalent resistance is given by 0 ohms, because here this branch is short circuited. Obviously, R equivalent is equal to 0 ohms. This is the answer for this. Next problem. Find equivalent resistance across the terminals X and Y. Here we have 4 resistors, R each of R ohms. Let me name the nodes. I would like to name this node as M and this as N, this as P, this as Q. Okay. I just want to redraw this circuit as this redrawing of circuit will help me to find equivalent resistance more easily. This is Y terminal and this is X terminal. So this is R ohms, same, and this is R ohms, and this is R ohms, this is R ohm. And you can see here this node is nothing but a common node. We can write P comma Q. This is node M and this is node N. From this circuit we can easily say that these two are in parallel. We can write 1 by R equivalent of this is 1 by R plus 1 by R, that equal to 2 by R, or R equivalent equal to R by 2. And we can write for this branch 1 by R equivalent equal to 1 by R plus 1 by R, that equal to 2 by R, or R equivalent equal to R by 2. Let me redraw the circuit. X, Y. And this is R by 2 ohms. This is R by 2 ohms. We can write equivalent resistance across XY equal to R by 2 plus R by 2 because these two resistors are in series. This can be written as R ohms. The answer is Rx equal to R ohms. This is the answer. Next problem, find equivalent resistance across the terminals XY shown in the circuit below. This is the circuit given. First, identify node points. This is a node point. I would like to name it as A. This is a node point. I would like to name it as B. Here I would like to name it as C. Okay. Here these three resistances are in parallel. I can write 1 by R equivalent equal to 1 by 1, 1 by 2 plus 1 by 5, which is equal to 17 by 10. That is, we can write R equivalent, or as it is across A and B, we can write RAB equal to 10 by 17 ohms. Next. Here these two resistances are in parallel. We can write here R1 by R BC equal to 1 by 3 plus 1 by 6. That equal to 3 by 6, which is equal to 1 by 2. RBC equal to 2 ohm. After simplifying these two things, let me redraw the circuit. Two ohms, and here we got 10 by 17 ohm, here 2 ohm, and here 5 ohm. From the figure you can see these three resistances are in series. Okay, so we can write series means we can write 2 plus 10 by 17 ohm plus 2 ohm, that equal to 4.9 ohm. We can just rewrite, we can just redraw the figure as 4.59 ohm Now we can write R equivalent can be written as 1 by Rxy equal to 1 by 5 plus 1 by 5.49. If you solve this, we'll get Rxy equal to 2.39 ohms. This is the answer. That's all for this video. Thank you.